There are three things and they're all interlinked. One is fractions, and the other one is percent, and the last one is ratio. Now all these three are related to each other. We're going to be dealing with them in sequence. Fractions, then I'll be going to percent, not in this one video, it's going to be spread over several. Then we'll be looking at ratio, and I will be explaining although there's a connection, there is a difference between these two. Okay, so let's look at a fraction. Now you have a number, whatever it is, and a line underneath and another number there. Oh, incidentally, this one here must never be 0. You cannot have 0 underneath. Not allowed. Mathematically, it's not allowed. So suppose we have, for example, 2 as the top number and 3 as the bottom number. I'm just picking them at random. Now these do have proper names, that is numerator and that is denominator. They have Latin roots, those names, but I'm not going to use those. I'm going to use words that describe what they actually do. Top one is actually a count, and the bottom one indicates the size of what it is you're counting. So it is a size indicator. I'm going to put IND for indicator. This is what I want you to remember. Yeah, okay, you've got proper names, you can remember those as well, but these are very important. They describe what they do. Think of numbers 1, 2, 3, 4 and so on. People don't do it, but it is perfectly correct to do this. This indicates the number underneath is a size indicator. Tells you how many of what you're counting it takes to make a complete one of something. So, and we're counting in ones. There's 2 lots of 1, 3 lots of 1, 4 lots of 1. So this is a very important and very appropriate number to be under there. So in fact it is the same structure, the same format as a fraction as you're used to thinking of them. You know, the 2 over 3, they are both the same format. This one takes 3 of what you're counting to make a complete one of something. As this is less than 3, we don't have a whole one of something. We have a smaller part of it. If this was, say, to be, I don't know, that's 7 over 3, it would take 3 of what we're counting to make a complete one of something. Well, 7 is 3 plus 3 plus 1. So we have a complete one of something, a complete one of something, and a part of something. So this is 2 and 1/3 of something. There's a complete one, there's a complete one, there's a part. 1, 2 of complete ones, 2 and 1/3. As we work our way through these examples, you will get more used to this. For fractions, we have 4 conditions. We have addition, subtraction, multiplication and divide. In this video we're going to be looking at that one. This one is fairly straightforward. That one needs a lot of thinking about. Consider as example we have 2 over 3 plus 4 over 3. Now because the number on top, the count, is greater than the size indicator, that means this is more than 1. The count is less than the size indicator, that means that's less than 1. Now we can directly add these because the size indicators are the same. We can directly add the counts. You cannot directly add the counts if the size indicators are different. 2 plus 4 over 3 over, I don't know, 2. Because these here are different, we cannot directly add the top numbers. We have to do a conversion. We have to make the bottom numbers, the size indicators, the same. Very important. They are the same here, so we can go 4 plus 2 is 6, but it does not change the size indicators. The size is the same. I've seen people do this. 2/3 plus 4/3, exactly the same as 2 plus 4 all over 3 plus 3, which equals 6 over 4, 5, 6, which equals 1. No, 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 you do not do that. It tells you what the size is of what you're counting. You don't do this. What you would have to do here is 2 plus 4, and they both have the same size indicators, so this is a way of showing that they share the same size indicator. So that would then give you 6 over 3. Okay, let's do some examples to demonstrate the method. Let's go for the 2 over 3 again. And I wish to add to that a half. Size indicators are not the same. We need to make them the same. So how can we do that? Now these two numbers here, we can make them fit into 6, because 3 times 2 equals 6. Now watch what happens. I'm going to put these in a square bracket. There's your 2/3. All it's doing is grouping things. It's not changing anything, it's just grouping things. Okay? Now, watch what I do here. Let's make those brackets a bit neater. There's my 2 over 3. I want to change it, the 3, such that it becomes 6. Now if I multiply that by 1, let me change the colour, times 1, it does not alter the value, does it? But 1 comes in many forms. The 3, if I want to change the 3 into a 6, I have to multiply it by 2. 2 times 3 is 6. So, let me get rid of that and change that. Just size. Come here. We're in the red. Now I want to change the 3 into 6. So I multiply that by 2. 2 times 3 is 6. But if I multiply the bottom by 2, I have to multiply the top by 2 as well. Put a line between those, and as a fraction, that is 1. That's this bracket here done. There's the plus, that plus there. here's the half. Again, if I want to multiply it by 1, I don't change it, but 1 comes in many forms. If I want the 2 to become 6, I multiply it by 3. So I have to multiply the bottom by 3. But I wish to multiply the whole thing by 1. So what I do is I do that. This is the same value as 1, so it does not alter anything. It just makes it look different. That's all I'm doing, making it look different. Now look, 3 times 2 is 6. 2 times 2 is 4. That's the plus. 2 times 3 is 6. 1 times 3 is 3. The bottom numbers are now the same. The size indicators are the same. So we can directly add the counts. 4 plus 3 is 7. So we have 7 over 6. I'm going to do another one. Let me get rid of this and put a line down here, and when the pen works, let's do another one. Suppose we have 3/4 and I want to add to that 1/8. Bottom numbers are not the same, so what we're counting does not have the same size. We change this here such that the 4 becomes 8. So let me put that in a bracket. All it's doing is grouping things, the bracket. It's not doing anything else. There's the 3 over 4. Now I want to change the 4 into 8. 4, change it into 8. Well, if I multiply that by 2, 2 times 4 is 8. So let's multiply it by 2. So 4 times 2 is 8. Multiply the bottom by 2, I have to multiply the top by 2. This is the same as multiplying it by 1. So we end up with that. With the multiply, there's the plus, that plus there, and there's the 8th. Now 4 times 2 is 8. 3 times 2 is 6. There's the plus, and there's the 8th. The size indicators are now the same, so I can directly add the counts, and that will give me 6 plus 1 is 7, and they are of size 8. Straightforward, isn't it? Let's do a couple more. Now it's awkward when you get what they call a prime number. Because of the level you're studying, you're not likely to be given that. So let's use, suppose we have 7 over 5. This is the size of what you're counting. We've got more than 5. So that means this whole thing here is greater than 1. Oh, by the way, look, greater than. Notice the gap is bigger that end than that end. So this number here is greater than 1. Right, that's just something you will come across at some point. And we want to add to that 16/10. Now again, because that number there is greater than, don't use the word bigger, that number there is greater than this, the whole thing is more than 1. So we're adding more than 1, more than 1, so it should be greater than 2. Right, now look, okay, we want these numbers here to be the same, the 5 and the 10. Again, just grouping the things. There's your 7 over 5. I'll put a bracket there like that. There's the plus, and there's the 16 over 10. Want the 5 to become 10, so I multiply it by 2. 2 times 5 is 10. Because I multiplied the bottom by 2, I multiply the top by 2. So effectively I'm multiplying the whole thing by 1. It just makes it look different. Okay, 5 times 2, let's change the colour back. 2 times 5 is 10. 2 times 7 is 14. Plus, we've already got that in the sizing we want. Because the bottom numbers are the same, the size indicates we can directly add the counts. 4 plus 6 is 10, carry 1. 1 plus 1 is 2, plus the 1 that's carried is 30 over 10. Now, I can simplify that. If I were, let me write it down below, 30 over 10. If I divide the top by 10, I have to divide the bottom by 10. Okay? That would give me, here we go, 30 divided by 10 is 3. 10 divided by 10 is 1. There you go, there's that 1 again, which is 3. We don't bother to write the 1, even though it's there. That's simplifying. One more, then we'll go into subtraction. Suppose we have 46 over 18 plus 9 over 6. Now again, notice the top numbers are greater than the bottom numbers in both cases. So these are not less than 1, they are greater than 1. We need the bottom numbers to be the same. I want to change the 6 into 18. And if I multiply that by 3, I get the 18. Okay, so here's the 46 over 18. There's the plus bracket. So all the bracket's doing is grouping things, nothing else. 9 over 6. Change the colour. 6, I want it to become 18. I have to multiply it by 3. If I multiply the bottom by 3, I have to multiply the top by 3. Bracket. Here we've got 46 by 18. We've not changed it. There's the plus. There's the line. 3 times 6 is 18. 3 times 9 is 27. Now they both have 18, so they share it, so we can put it like that. That's what it means, is that each of these numbers on the top share the 18 as the size indicator, denominator. So we have 46 plus 27, so the answer there is all over 18. 7 and 6 is 13, carry 1. So that's 3 and 4 gives me 7. There you go. Addition. Addition. Now how do I approach subtraction? Something I need to show you. Look, if I have a pen that works, 3. Now I'm going to put that in a bracket, multiplied by -1. If that's a plus, when you're multiplying, if the signs are different, the answer is negative. Don't use minus. It's a negative value. I can split 3 into 2 plus 1. It is still 3. Now if I multiply that by -1, these two are positive, that is negative, so we're multiplying a negative by a positive, so the answer is negative. 2 plus 1 is 3. Once times 3 is 3. I'm trying to get at the fact of what you do with a bracket here. If that is some unknown value, which I'll write as A, and that is another unknown value, we don't know what they are, we know they exist, so we're showing they exist. And I say multiply it by that, let's keep it positive, 2. I multiply everything inside that bracket by 2. Or if that's negative, I multiply everything inside that bracket by -2. Very important fact. Okay, subtraction. 4 over 8. Subtract from that 2 over 8. The size indicators are the same. So we can directly apply the action of subtraction to the counts. So the answer will be 8s because it matches these. Got 4, remove 2, the answer is 2. Alright. (15 over 7) remove 8 over 7. Because the size indicators are the same, we can directly subtract the 8 from the 15. And the answer is still of size 17. Let's find 7. Now because that number is the same as that number, that means it equals 1. What about if we have 8 over 7, remove 15 over 7? What do we do there? We're talking about negative numbers here as an answer. Notice I didn't say minus numbers, it's negative numbers. Well, let me split this here. Let's split this one. We've got 8 over 7 minus, now I'm going to multiply everything inside the bracket by 1. Now I can split this into 8 over 7 plus 7 over 7. 7 and 8 is 15. Now those two there make that. Multiply by -1 outside, it makes that. Everything in here is multiplied by -1, so we have 8 over 7. Once times that is that. This is positive, that is negative. The signs are different, so that is negative. Here, once times that is that. Positive times a negative, the signs are different, so that is negative. Those two are the same. So we're subtracting that from that, which gives me 0, the answer is 7/7, which is 1. This is where people start to get confused when you have negative numbers, but the principle still applies. You cannot directly do your subtraction unless the bottom numbers are the same. These tell you the size of what you're counting. These are the counts. Let's do another one. Suppose we have 4/2, and I want to subtract from that 6/2. Okay, here we go. There's your 4/2. Subtract from that 1 times. Now, a lot of this, when you practice, you'll be able to do in your head. You won't need to write the whole thing out. 6/2. We make that 4 plus 2 is equal to the 6. That is over 2. That is over 2. Together, these two make that, ignoring the sign. 4 plus 2 is 6. They are a size 2, which matches that. Multiply everything inside the bracket by -1. So we end up with 4/2. 1 times that is that, which is 4/2. That is positive, that is negative. The signs are not the same, so that is negative. 1 times that is the same, 2/2. That's positive, that's negative, so the sign is negative. Those counts are the same, so that becomes 0, and we're left with negative 2/2. Those numbers are the same, so it is 1. It feels quite daunting for some people when they first come across this. Others are okay with it, but some find it rather daunting. It's a matter of getting used to it. It's a matter of getting used to it. Okay, we have done addition and subtraction. What I've not done is subtraction if the counts, if the size indicators are not the same. It's the same principle as before, though. Let's do one. Let's go for 3. 3/2. Subtract from that 1/8. Now this time that is less than that, so that's fine. You know, a way of writing that, 3/2 is such that 3/2 is greater than 1/8. Or if you read it the other way round, 8 is less than 3/2. The gap between the lines is 0, the gap is greater, so this is the greater value. Okay, want these bottom numbers to be the same. 2, I want to have it such that the 2 becomes 8. So if I multiply that by 4, 2 times 4 is 8. So we have the 3/2. Again, I'm going to use bracket just to group things. It does nothing else. And let's put the other bracket in here. Change colour. I want to change the 2 into 8, so I multiply it by 4. Because I multiplied the bottom by 4, I have to multiply the top by 4 as well. There's the minus 1/8. Nothing's changed. That is exactly the same as that, really. It's just going to look different. 3 times 4 is 12. 2 times 4 is 8. There's the minus, that minus there. There's the 1/8. Because the bottom numbers are the same, we can directly subtract the 1 from the 12. So the answer there is 11/8. Practice sum. Check it on a calculator. It is by repeated use that you remember. If you don't repeat it, you're not going to remember it unless you're lucky to have a photographic memory. I met someone once who really did have one. I don't. Practice, practice, practice.